everyone, my name is Rashmi Andapalli. I'm a Principal Product Manager in Azure Networking, and today I'm going to cover how to architect and simplify hybrid networking with Azure Virtual WAN. We also have a key announcement from one of our SD-WAN partners that I'll also go over shortly. There's a ton of topics today, so if I'm going very fast, I apologize. Feel free to check out the documentation on the Azure Virtual WAN page. So on the topics, we are going to first cover the Azure Virtual WAN overview, followed by the announcements. We'll touch on monitoring, then we'll look at some detailed transit routing use cases, followed by an integrated network virtual appliance demo, and then it will be a wrap. So what is Azure Virtual WAN? Virtual WAN is basically a unified framework for networking, security, and routing. You can connect, you can globally transit, you can secure it, you can do multiple routing functionalities, and we also now provide the ability to deploy a network virtual appliance inside the virtual WAN hubs. So let's go over each one of those pillars one by one. On the connectivity side, you can connect in from branches through site-to-site VPN, from remote users through point-to-site VPN, and for private connectivity, you can connect to the express route mechanisms. For site-to-site VPN, we support all the standard protocols for IPsec. So we allow IPv1, IPv2. We have partnerships with multiple VPN and SD-WANs, CPE providers. They have different solutions, but the automation that kicks in is the automation of IPsec from their device to the Azure VPN gateways. In terms of scale, we support up to 1,000 connections per hub. There is a hub in every region, and each one of those connections is an active deployment. So you can pretty much do 1,000 branches in every region. In terms of aggregate capacity, we support up to 20 Gbps for that VPN gateway. Some of the new capabilities that we have recently introduced are the FQDN-based IPsec. This assumes that the VPN gateway can reach the DNS server that's hosting the FQDN. There's also custom BGP or the APIPA support that is also available. It is for the 169.254 address space. So take a look at that. For point-to-site VPN, we support IPv2 and the OpenVPN protocol. There is also an Azure VPN client that you can download and you can connect to Azure Virtual WAN. But you can also use other clients like other IPv2 or OpenVPN clients that are out there. In terms of authentication, we support both CERT-based and radius-based authentication. And in terms of scale, we support up to 10,000 users, and we'll probably be supporting more, as well as the aggregate capacity of 20 Gbps. Recently, we also announced the capability to add custom DNS, and this is also something that you can try out. In terms of express route, there is support for encryption with the Azure native VPN gateway. In terms of scale, we support up to 20 Gbps, which is again aggregate throughput of the express route gateway. And the two new features that we are very happy to announce are the ability to connect up to 8 circuit connections per region. So you have one hub per region and you can connect up to 8 circuits. And you can also connect standard circuits now. So earlier you had the capability to attach premium circuits. Now we have opened it up. You can also attach standard circuits to any hub. Okay, so now the key part of the announcement is all the partnerships. So there are 3 kinds of partners. In Virtual WAN, we have partners that automate connectivity from their devices into the Azure Virtual WAN VPN. We have partners such as the MSPs like the telcos or the SIs that are the system integrators that provide end-to-end connectivity services with Virtual WAN. And also partners, the recent addition, which is basically the ability to provide a network virtual appliance and deploy them inside the hub. A recent addition is Barracuda, and we are very pleased to add Cisco to the mix. The 2 other partners that I want to call out are Aruba and Open Systems that we have also added to the VPN SD-WAN device automation on the left-hand side. And on the right-hand side, Cisco is the latest addition for which we will have a demo coming up shortly. Okay, so moving on. In terms of the second pillar of global transit architecture, what this means is you get a fully meshed hub. So when you deploy a virtual WAN hub and you have multiple hubs in the virtual WAN, all of those hubs are fully meshed and you can have any-to-any connectivity. So you can connect a branch, a remote user to Azure, but not just to Azure. You can actually interconnect. So you can interconnect an express route endpoint to a remote user or to a branch that is behind and site-to-site VPN. So you get all this transit functionality, including VNet to VNet, through this fully meshed hub system through the global transit architecture. The third aspect of virtual WAN is routing. Every hub has a router, and each router basically controls all the routes with all the other gateways in the virtual WAN hub. This router also provides the VNet to VNet transit capability, so the packet is actually flowing through the router, and the aggregate capacity is 50 Gbps. Recently, we also announced the capabilities of custom routing, and I'm going to go over a lot of those capabilities when I cover the transit routing use cases. The fourth section of Azure Virtual WAN is a secure virtual hub, which is nothing but a virtual WAN hub. And again, a hub is per region, and it's a hub with a firewall in it. So you can deploy multiple firewalls. You can use the Azure Firewall Manager to create policies and apply across multiple firewalls. You can work across regions, subscriptions, deployments. You can secure internet and private traffic, where private is VNet or branches. And with the Firewall Manager, you have the additional capabilities in virtual WAN to set up policies where you can steer the traffic to security as a service partner, such as the Zscaler, iBoss, and Checkpoint companies. The fifth part is the integrated network virtual appliance. Here you have the ability to deploy a marketplace-based appliance inside the virtual WAN hub. And what it gives you is the integration with virtual WAN. All the transit scenarios are supported with the SD-WAN appliances that are deployed in here. So you can connect an SD-WAN branch to, let's say, an express route endpoint and so on. There is also the additional capability of SASE, which is Secure Access Service Edge. And this is basically a combo of SD-WAN and security through the Azure Firewall. There is built-in resiliency, so you don't have to deploy your VM, NVAs, and manage them. This is just built-in, and it just comes with the package. There is no hassle routing, and what that means is you don't have to deploy user-defined routes or UDRs to your NVAs. As soon as you put the NVA inside the virtual hub, the routing kicks in. There is BGP between the NVA and the virtual hub router, and it's just a one happy family inside the hub of gateways. And last but not the least, the cool value prop is this virtual appliance provider can actually keep their secret sauce or the proprietary IP because it keeps all the features intact. So in the SD-WAN world, these branch devices have to talk to their sister counterpart gateways. In order to do that, they basically have to communicate with each other, and they have this proprietary information which gives them the ability to do all these cool SD-WAN functionalities like path selection, application-based routing, different kinds of link aggregation, and so on. So that also is intact now. So basically you get the best of both worlds. You get the SD-WAN capability, you get the Azure native capabilities of built-in resiliency, no hassle routing, and you get to enjoy all the other feature sets in Azure Virtual WAN. So let's put it together. A lot of our customers, they ask us, how is this different from what we do today in Azure? It is a lot different, and let me walk you through it. So when you want to do this yourself, you can deploy an express route and use a VPN, a site-to-site VPN, a VNet, or a firewall. You can do that. In virtual WAN also you do it, but it just makes it easier for you. And who wouldn't want that? So basically here's a hub with a bunch of VNets. There's a hub with a firewall in it, which is the right side. And what you also see is a bunch of branches and some VNets here. Now this is something you can do outside. Now, but in vWAN, you basically have scale. So you have 20 Gbps aggregate capacity for the site-to-site VPN, for the point-to-site VPN, which is a different gateway, for express route. And if you wanted to do VNet to VNet transit, you also get 50 Gbps. So all of the scale is built in. And to add to that, the unique capabilities are with express route, you get encryption. With point to site, you get the global traffic manager, which means if the user is a global user, they're in one country at one point and another country at another point. And if they have downloaded the global config, then they can connect to multiple hubs and be able to reach the Azure resources. We talked about the site-to-site connectivity automation partners. That's also unique to Virtual WAN. And then, of course, we also spoke about the firewall manager partners, which is the security as a service partners like the Zscalers, the iBoss, and Checkpoint. So if you look at the flow, you have a fully meshed hub, you have different kinds of flows, and you can pretty much do any-to-any connectivity, all of this seamlessly in Virtual WAN. Now, the routing capabilities in Virtual WAN are unique. So you get a Microsoft managed hub. It's a managed service. And this hub has a router, which provides you all this fully mesh and the transit capabilities with custom routing and the integrated virtual appliance scenarios. So what's the pricing? This is a question we get often. The pricing principles are also very simple. You just pay for what you use. It's not like you have to pay an entire set of, a price for functionality that you may not be using. Basically, whatever you use is what you pay. The concepts are very simple. Each one of the site-to-site, expressor and point-to-site capabilities, they have gateways, and so you pay for the throughput. So 500 Mbps is one scale unit, so you pay for the scale unit. As you connect in users, you pay for the users or the branches. And then for the firewall and the virtual hub, there is a per hour and a per GB charge. So if there's no traffic flowing through it, there is no charge. And in terms of hub to hub, so if you have, let's say, a data center in West US, and if you had a data center in Australia, you have to put together an entire machinery to connect that up. In this, you don't have to do any of that. All you have to do is provision those hubs, and the fully meshed hubs just gives you those capabilities. And the charges are basically egress only. So if you're going from West US to Australia, you're going to pay for the traffic that leaves West US. There is no inbound charges anywhere. And let's say if you're going from West US to Europe, you're going to pay a different charge. So that's basically the philosophy of virtual WAN, to bring in this network security and routing using the Microsoft global backbone, and that's key. So Microsoft's POPs and the edges and the data centers are pretty much everywhere on the planet. And so when an ISP connects any of the on-premise endpoints to the closest Microsoft edge, it drives the entire Microsoft backbone, this cold potato routing enabled in the system, due to which your user gets to the other end as fast as they can. So in terms of monitoring, so you have all this capability, you obviously need to be able to see it. So very pleased to announce monitoring insights. You have a lovely button here. You can see the entire topology. We've also built in a bunch of metrics like bandwidth, throughput, etc. also in there. So give it a check. Let's move on to the transit routing use cases. This is where we will take a detailed look at all the scenarios. So first, let's understand the concepts. When you have S2S sites or point-to-site users or express routes, you basically connect them with a connection resource. And they are all connection resources that are connecting those endpoints to some gateway inside the virtual WAN hub. Similarly, for VNets, you have the virtual network connections. Now, these connections, they have to get to each other or somewhere through some routes. And in order for them to get to some destination or to be able to access destination, they need to be associated to a route table. Once they associate to a route table, they learn the routes from those route tables. Similarly, let's say all the VNets and all these branches, they're associated to a default route table. And once they're associated to a default route table, they need to be able to get or be able to access something. This is where these connections, they propagate routes to a route table. So let's say VNet 1 is propagating its route to the default route table. This is how the default route table gets the route or learns about the routes dynamically. So here I have propagated the routes from all my branches, which is the 192 address prefixes, and all my VNets, which is the 10 address prefixes. And because all these routes, they all show up in the default route table, and if all these VNets and branches associate their connections to this route table, this is how they get the any-to-any connectivity. So moving on, there's a new concept of custom route tables. VNets can associate to custom route tables. Branches cannot associate to custom route tables. And when I say branches, it means site to site, point to site, and express route. So let's say we have a custom route table called RT VNet. VNet 1 is associated to it, and it also propagates its route to it. So the route gets into the route table dynamically. And let's just say that VNet 2 also propagates to it. Now what this means is both these VNets have propagated the routes into this route table. And for this example, let's assume that the VNets, in order to get to these branches, they need to be able to get through a virtual appliance, which is sitting in a third leg. It's sitting inside this VNet 3. So in order to do that, you would actually go ahead and add a static route for these branch prefixes. So you can aggregate them. So I have aggregated it here. And the next hop is this VNet 3 connection. But then in order for the traffic to go from VNets to these branches via this pink dot, which is a virtual appliance, there needs to be somewhere we need to enter this IP. This is where you are actually going to add a next hop IP in that connection resource. So with a very simple way, you basically done this. Now let's look at it, how you isolate VNets. So in this use case, you basically have two VNets, some branches, and you want the branches to be able to connect to each other, the branches to be able to reach VNets, but the VNets need to be isolated. So let's start with the default route table. The branches, they associate to the default route table. And because we want to isolate VNets, we want to customize how the traffic flows. So we will create a custom route table. In this case, we have created RT VNet. the VNets are associated to it. Because the branches need to be able to get to each other and they associate to the default route table, they'll propagate, which are these yellow lines, to the default route table. The branches, they need to be also able to get to VNets, which means the VNets, they need to be able to propagate their routes into these route table. Also, the branches are required to be propagating to the custom route table because the VNets are associated to the custom route table. And if they see the routes of the branches, that's how they know how to get to the branches. Now, with a very simple way of association and propagation, you have simply isolated the VNets and still kept the flows between VNets and branches. The next use case is how to route to a shared services VNet. So let's say we take the same setup. We have a shared services VNet and we have an entire network behind it. And it's like a one-way street. So let's say VNet 1 wants to get to another network behind this VNet. And it has a shared services VM. And that's why I'm calling this a shared services VNet. Branches, they need to be able to get to each other. Branches need to be able to get to VNets, all the VNet 1, 2, and 3s. But VNet 1 and 2, they need to be able to get to this network. So how do we do that? So branches, they associate to the default route table. They will propagate to the default route table. Because they need to be able to get to VNet 3, VNet 1, and 2. So all of these VNets will propagate to this route table as well. The VNets 1 and 2, they associate to the RT VNet, which is the custom route table. Because they have to get to the branches, so the branches, they propagate to the custom route table. And because these VNets need to get to VNet 3, so VNet 3 also propagates to this custom route table. With this very simple association propagation, we've essentially now steered traffic in a different way to a shared services VNet. The next use case is the custom isolation VNet. Here, I have a setup where I have a blue VNet and a pink VNet. And basically, the concept is that I want the blue VNets to be able to get to each other, the pinks to be able to get to each other, and the VNets, they should all be reachable from all the branches. Now, in order to do that, we would have a default route table and all of the branches, they would propagate to it because the branches need to be able to get to each other. So they need to see the routes. Then for the custom route tables, because we want to isolate the pink and the blue VNets, we would have custom route tables, the blue VNet, and there's a custom route table for the pink VNet. And this is where I want to introduce the concept of labels. Labels are logical grouping of route tables. So if you wanted to send traffic to multiple route tables, you wanted to have routes for multiple route tables, then you would propagate to a label. And this would just propagate to all the route tables with those labels. So in this case, all of the blue VNets are associated to the blue custom route table and the pink VNet is associated to the pink route table. And the branches, they need to be able to get to the blues, and the pink VNets, they need to be able to get to the branches. So obviously the branches have to propagate to the blue and the pink route table. Similarly, because the blues have to get to each other, so all of the blues, they are going to be propagating to the custom route table blue, and the pinks are going to be all propagating to the custom route table pink. With this, the last step would be to make sure that the branches are able to get to these blue and pinks. So that's why all of this blue and pink VNets, they should be propagating to the default route table because that's what the branches are associated to. The next use case is where we take a closer look at the routing configuration. So with any-to-any, the default route table gets all the routes of all these connections, the VNet connections, the branch connections. And this is what gives you any-to-any. But actually what's happening is the routing configuration of this VNet and the branch connections, they are getting the association and the propagation set to the right route tables due to which they're able to support these flows. The next one, we mix it up a bit. Basically, we take the previous use case where we have a default any-to-any, but we have a firewall in the mix. If you use a firewall manager UI, the routing is taken care of. It is abstracted for you. The user goes and picks an option to secure internet traffic, which is where Azure becomes the internet edge. So you can do VNet to internet via the Azure firewall, branch to internet via the Azure firewall. And for the private traffic, let's say you decide to go direct, all you have to do is in the Azure Firewall Manager UI, secure internet traffic, and the routing kicks in, which basically is a static route of 00 with next hop Azure Firewall in the default route table. Very simple. The next use case is one of the most prominent use cases where customers want to be able to route traffic through virtual appliances. So here I have a pink dot in both these VNets, VNet 2 and VNet 4, and this is an NVA or network virtual appliance. Let's say they have an entire network behind it and they want to be able to do VNet to VNet. So in order to do VNet to VNet, this is the topology that is supported in virtual WAN. Currently, we do not support the ability for going from VNet to VNet through another virtual appliance which is sitting in a third VNet, but that's in our roadmap. So let's say you have this network and you have a default route table set up with all the branches and the VNet spokes propagating to it. So in here, the steps are, you would first define the UDRs or the routes from this indirect VNets to the NVA VNet. The second step would be to ensure that there is a static route to get to the NVA connections, and those you would add to the default route table. And then the third step would be to make sure that you specify the NVA IP in that VNet connection. So this is how you get routing through the NVAs, and you can basically mix and match it up with the other use cases to give you all the flows. And in this case, you get the V2V flows. You can get across hubs within the hub. You can get branch to VNet across hub within the hub. And you can also get the internet cutout flows in here. Let's take a closer look at the portal. In the portal, every hub has a routing section, and inside the routing section, you can basically create a route table. You can set up the static routes in the basic tab. You can set up labels. You can associate the connections. So when you pick connections here, all you're doing is you're associating those connections to this route table. You can propagate the routes from connections. So when you're selecting, let's say, a VNet connection in this dropdown, what you're saying is propagate routes from that VNet connection to this route table. Also, you can look at the effective routes of a route table. And here, as you can see the next hop, you can see origin from where this route was learned, and you have a lot of information through which you can do some troubleshooting. To summarize, branches are all collectively terms for site-to-site, point-to-site, and express route connection. They associate to default route table and they propagate to the same set of route tables. So let's say branch A propagates to route table A, and branch B also will propagate to route table A. Similarly, for custom route tables, you have certain abilities. Custom route tables, they apply to VNets. You can set up static routes, you can view effective routes. And the last concept here is, if you did not want to propagate routes, you can propagate to something called a non-route table, which basically is saying that the connection does not want to propagate the route to any route table. The next section is basically the integrated virtual appliance. Very pleased to announce the Cisco Viptela NVA now available in Virtual Hub. It supports transit. As I mentioned before, there's the entire SASE framework. There's built-in resiliency. There's no hassle routing. So let's hear from our Cisco folks.
This video describes Cisco SD-WAN and Microsoft Virtual WAN integration. I'm Nikolai Pitayev, Senior TME, SD-WAN Solution Team. Let's get started. On the left side, you see SD-WAN branch with multiple teams accessing applications in a data center. In the last years, you see applications moving from on-prem data center to Azure because of multiple reasons like cost saving and agile development. So the key question now is how to connect SD-WAN with Azure in secure, reliable, and automated way. Cisco Cloud On-Ramp solution for IaaS integrates CSR 1000V with Virtual WAN. Traditional solution requires two different UIs, vManage for SD-WAN and Azure Portal for Virtual WAN configuration. After 17.4 iOS XE SD-WAN release, the whole interconnection workflow will be done in single UI in vManage. Before Cisco SD-WAN and Azure vWAN integration, the solution used gateway VNet in the middle with two CSRs connected to host VNets via standard IPsec tunnels. We used BGP on top of it and OMP to BGP redistribution. The new Cloud On-Ramp for IaaS vWAN integration dramatically simplifies the network design, introducing two CSRs in the middle, connecting directly to vWAN and providing connectivity between SD-WAN network on the left side and host VNets cloud infrastructure on the right side. This is how the whole workflow looks like in vManage. First of all, you will need to do some basic configuration like providing your Azure credentials and generic configuration like CSR version. Then you will be discovering and tagging host VNets, then setting up cloud gateway and mapping VNets to SD-WAN service VPNs. Let us see it in a short demo. First of all, we will select Microsoft Azure and provide some basic details as account name, client ID, secret key, and description. Once we have the account saved, then we can spin up cloud gateways to CSRs. So we will provide some basic information like name, description. We will select the account needs to be used, and two CSR UUIDs, basically two CSR licenses. Once we hit save, vManage will go ahead and bring up both CSRs on Azure and integrate this with Microsoft Virtual WAN. As you see here, both CSRs are up and running. Next step is to tag two host VNets. I will be using just a demo tag for both of host VNets, and that will be used later on in the last step for interconnection between host VNets and SD-WAN infrastructure. Once I defined my tags, then I can execute my last step, which is mapping between Azure VNets and SD-WAN VPN. That's it. We successfully connected Cisco SD-WAN and Azure infrastructure. So let me conclude with the following statement. You have Cisco SD-WAN with different transports, MPLS, Internet LTE, data centers, and branches connected. And now you've got public cloud, Microsoft Azure, with VMs, containers on it. The question is how to interconnect Cisco SD-WAN and Microsoft Azure in secure, automated, and reliable way. Between SD-WAN and Azure, there's a bridge, cloud on-ramp for IaaS.
All right, so that gets us to the end of our presentation. So let's summarize. Virtual WAN provides you unified framework for connecting, routing, and securing through the Azure firewall. It's deployed in a hub and spoke architecture so that you can architect your network, re-architect it, scale it, or simply just simplify it. Thank you for watching.